right. Good morning or good afternoon or good evening, whatever time it happens to be when you're listening to this. This is Channel Chat, Zyxel Network's North American podcast. Today, we're going to be talking about things you should know before upgrading to Wi-Fi 7. My name is Shawn Rogers. I'm the wireless product manager here for North America, and with me is our sales engineer, Marcus.
Hey, Shawn, thanks for having me.
Yeah, glad you could join us. I think we're going to get started today just by jumping right into it. And I wanted to start by talking a little bit about the history of Wi-Fi. Um, so, this sort of ties into some of the things that Wi-Fi 7 brings us and some of the limitations on what's going on with Wi-Fi 7. Wi-Fi itself, or the 802.11, 802.11a, 802.11b, they're over 25 years old. So these were standards that were created all the way back in the 1990s, well before, video streaming, voice over Wi-Fi, everybody having at least one, if not multiple Wi-Fi enabled devices. So when they were creating Wi-Fi, they weren't really thinking about these sorts of applications. They were just thinking about basic file transfers, checking email, things like that. And so because of that, there are things that they didn't think were important to put in the standards that today are sort of biting us in the behind. Um, so over the years, we've been slowly increasing and improving on Wi-Fi, but most of those um, changes have been all about increasing the amount of bandwidth that's available, increasing the encoding so you can cram more data into the same amount of radio waves, but really not a lot of changes to how the core Wi-Fi functionality worked. Back in 2019, they finally came out with what we now call Wi-Fi 6 or 802.11be, um, which was the first attempt to sort of start making some of those changes and fixing some of those things that have been holding Wi-Fi back. And then the have since about what has it been about 3 years after that, 4 years after that, they came out with Wi-Fi 7. So Wi-Fi 6 was sort of a transitory technology. It was there to start testing some of those changes and to see, just how much we could change the Wi-Fi standard without breaking backwards compatibility or causing issues for older clients. And Wi-Fi 7 now is sort of like the full-fledged adoption of that and really embracing some of these big changes to change the way Wi-Fi performs. So at this point, Marcus, maybe I'll throw this over to you. Do you want to list maybe some of the common problems that people run into when deploying Wi-Fi, especially in business environments, hospitality, things like that?
Yeah, sure. A lot of things that we've seen specifically is kind of a general misunderstanding about Wi-Fi in general. They'll look at the stats of an access point and think, okay, well, it can go 200, 300 feet, but they don't really think about the clients themselves. Usually the client itself doesn't have the type of power that the access points do to throw the signal back. And so you kind of have to think about how far the reality of how far you can actually push a signal. So that's one of the things that we kind of keep in mind when deploying Wi-Fi for businesses. And then we also have to think about density. How many clients are we going to be loading up on an access point? And I know that there are some things that we'll probably talk about in Wi-Fi 6 and Wi-Fi 7 that kind of solves some of those problems and challenges. But it's something that you have to think about, something that um, is very important considering the amount of density for your Wi-Fi users on an access point.
Okay. Anything else you wanted to add there?
Let's see. Well, we also have the thoughts about, say, your environment. So when you start looking at your Wi-Fi signals going through an environment, you're looking at what type of signal you have to go through when it comes to specific your walls, the type of walls you're going to, the material that the signal has to go through. So that's something that we have to take into account as well. We have on our access points, we have smart antenna that does help to push the signal to where the clients are using different Wi-Fi algorithms to kind of push the signal to where the clients are. So that's something that we also have with our Wi-Fi access points.
Okay. And then I just wanted to add a couple things to that. I think another area where we tend to run into some issues with this um, is just the limited amount of bandwidth that's available. A lot of people don't realize just how little, for instance, 2.4 bandwidth is there. Um,
Correct.
One of the the challenges there is you've got basically 60 megahertz of spectrum, and that has to be shared with every not only 2.4 gigahertz wireless device, but it has to be shared with Bluetooth devices, a number of non-Bluetooth things that use wireless, such as certain types of gaming wireless keyboards, wireless mice, wireless controllers. Those are using 2.4 cameras. So that's all having to be shared. And each device has to take turns. So you can't just have multiple devices cannot broadcast at the same time. And that's something I think a lot of people don't understand is that each device has to take turns. And when multiple devices broadcast at the same time, it causes interference and basically causes the data for both devices to be dropped. And that's where a lot of the issues that we run into comes from is channel utilization. Basically, the channel you're using has just too many devices trying to use it at the same time, and they might not all be wireless clients for that access point. They may be wireless clients for other access points that are nearby, but they might also be these other types of devices I was talking about that are there. 5 gigahertz was supposed to sort of solve that for us. It opened up a lot more spectrum, but the challenge we ran into with 5 gigahertz is these things called DFS channels. So
Mhm.
DFS has to do with the fact 5 gigahertz, before it was opened up and anybody could use it, it was licensed spectrum. You had to go to the FCC and buy a license and jump through a bunch of hoops before you could use it. So when they opened it back up for Wi-Fi use or unlicensed use, um, they had to come up with a way to play nice to those existing users who had paid, for exclusive use of the spectrum in their area. And that's not only just devices that are maybe broadcasting, but it's also used by things like radar, both
Mhm.
weather radar and airport radar and things like that. So they came up with this DFS system where before you can broadcast, you have to listen and make sure none of the legacy users are using that channel. Then you can start broadcasting. And then if you detect one of these legacy users, you have to stop using it, disconnect your clients, and move on. And so for those reasons, a lot of business users don't want to use these DFS channels because it causes disconnections and delays and issues with their users at random times because the access point just has to sort of guess, wait a minute, I'm seeing something, I don't know what it is. It may be a legacy user. I have to stop working now for however long period of time it may be. The other challenge you run into is getting DFS certification can add up to 6 months to the certification process. And in technology where everyone's rushing to be first to market, companies don't want to wait 6 months to launch their product. And so, because of that, particularly on consumer class devices, a lot of consumer devices do not support DFS channels. Um, and so that means that if you're using DFS channels in your Wi-Fi deployment and you've bought a cheap laptop or someone's bringing their own phone from home, it may not work with those DFS channels. And suddenly you go into a certain part of the office, they don't have connectivity. And that's why it's because their device doesn't support the channels you're using. So that drastically reduces the amount of channels that are available in 5 gigahertz for people to be able to use.
Yeah, and also you have access points such as ours that actually have the ability to not broadcast on the specific DFS channels. I believe there's 8 of them within the 5 gigahertz spectrum, so that you can make sure that your access point does not broadcast using those channels. Another thing that you brought up that kind of reminded me of something is one of the challenges that we kind of see specifically with a lot of signals in the area, and you brought it up, is some people just don't do site surveys. So I can give you a specific case. We dealt with a customer who had a hotel that was above a shopping mall, and this particular shopping mall was on the first floor. Now, each individual store in the shopping mall, they have their own router. So, they're just broadcasting on whatever channel that they want. And so, without doing a site survey, they wouldn't know exactly, well, these stores are broadcasting on a specific channel. We need to steer our access points away from those channels. We know there is dynamic channel selection that you can use, but for this particular customer, it was best for him to hard code the channel specifically for his access points to avoid interfering with other access points that he had no control over. So a site survey is very, very important and a very important tool to use when thinking about Wi-Fi deployment, because it tells you exactly what's in your environment, what's around you, and then what channels are being broadcast on other devices that you don't have access to or control over.
And just to add to that, it also tells you, what your coverage actually is in the physical environment. You can look at floor plans and make some guesses, but how you think the radio waves should be broadcast and how they actually behave in the real environment are very different things. I would say the vast majority of our support calls about Wi-Fi boil down to we didn't do a site survey, we just threw up some access points, and now
Right.
we've got issues um,
Hmm.
for those various reasons. The other thing, just sort of also tying back into that in DFS, is when you're looking at the speeds being quoted on Wi-Fi products, they're assuming you're using the maximum bandwidth that's available. So for Wi-Fi 6 and earlier, that was 160 megahertz channels. Now, in 5 gigahertz, there are only two 160 megahertz channels that are available. So the first problem you're going to run into is um, those 160 megahertz channels overlap DFS. So in
Hmm.
order to use 160 megahertz channels, your client devices must support DFS. And again, a lot of consumer products don't. And then second to that is there's only two available, which means as soon as you throw in a third access point, it has to be using the same channel as one of your already two deployed access points. And you've now got to deal with interference between those two access points. So in the real world, you're not going to be seeing those speeds for lots of different reasons that we won't get into in today's podcast. Um,
Right.
but that's one of the reasons is you're probably going to have to drop to 80 megahertz or 40 megahertz channels on 5 gigahertz. And in 2.4, you're going to have to be using 20 megahertz channels just to deal with avoiding that interference from other devices or other access points that you're deploying. Unless you had something else, Marcus, I'm ready to move on.
Oh, go ahead.
Okay, so I want to start talking now about Wi-Fi 7. Whoops, I scored a little too far in my notes. Specifically, what are the big promises that Wi-Fi 7 tells us? How is it that Wi-Fi 7 is improving things? And Marcus, I'll throw it over to you to start.
Right. So we're when Wi-Fi 7, we have color coding that we can kind of go into a technical discussion about that. But I think the real thing that Wi-Fi 7 brings is the increased speeds with the advent of MLO, multiple link operation, which is kind of like bridging your radios together to get an aggregate throughput. I think that's a huge bonus and something that a lot of people are looking forward to. I think currently right now, I want to say only two cards right now on the market support it at this time. I think it's a Qualcomm and a Broadcom chip that support MLO. But I think that once that becomes more prevalent, I think that's going to be a huge boost for overall throughput because I think that as the technology increases, as we go from each technological step up for Wi-Fi, we're seeing a huge increase of the amount of speeds and the amount of sustained speeds that can be held over multiple connections, having more and more people on the access point to be able to share that same throughput and the same speed. So I think that's where Wi-Fi 7 has the promise over Wi-Fi 6 and earlier technologies.
Okay, it's a good starting point. I think some of the other things to hit on here, one of the challenges again with Wi-Fi in general has been the interference issues between different devices. So you brought it up just briefly there, but we have the ability now with Wi-Fi 7 to add a little extra data into the packets being sent to identify which device those packets are for. So
Right.
that way, you solve some of the interference issues because your access point is able to say, oh, that packet isn't for me. I don't need to pay attention to it. So that's something that helps solve some of those congestion issues for us. We
Right.
also now have the ability. So in the past with Wi-Fi, again, each device in general has to take turns broadcasting. There is technology known as MIMO, which does allow multiple devices to broadcast at the same time, but generally only two or three. And the trade-off is you're cutting down how much data each one of those can send or receive at a time. So just to keep things simple, we'll ignore that. As a general rule, each device has to take turns broadcasting. So Wi-Fi 7 finally adds the ability there for the access point to help schedule the clients and tell them when it's their turn. Where in the past, what happened is devices just had to sort of guess. They could listen first to see if they heard anybody else broadcasting, and then they would broadcast if they didn't hear anybody. But as you add more and more devices onto your Wi-Fi network, the more likely it is two or more devices would choose to broadcast at the same time, um, because they would both listen at the same time, both not hear anything, and then both choose to broadcast. You also have an issue with what's called a hidden node problem, where an access point can hear both clients, but the clients are far enough from each other that they can't hear each other. Um, so that also causes some interference issues here. And this sort of helps solve some of those issues and lets us get these denser deployments. We also have a new technology called RU puncturing. And so what this has to do with is, again, we're using these larger channels. With Wi-Fi 6, it was 160 megahertz channels. With Wi-Fi 7, the 5 gigahertz radio can now use a 240 megahertz channel. Your 6 gigahertz clients or operations can now use up to a 320 megahertz channel. But the challenge is when you're using those bigger challenges is interference anywhere in that channel that you're using interferes with the entire broadcast. So with Wi-Fi 7, they've got the ability now for you to detect that there's interference on your big channel and where in that big channel the interference or overlap is happening, and to allow you to essentially stop using that chunk of spectrum. So let's say you're using a 360 or 320 megahertz channel and you're getting interference from some other neighboring device that's using 20 megahertz of your 320. Now, instead of basically throwing out the entire thing that's been broadcast, you can now dial back and say, okay, well, instead of using 320 megahertz channel, I'll use a 300 megahertz channel and skip that 20 megahertz where the interference is on, allowing you now to use a 300 megahertz channel without having to worry about those interference issues. Um, And then another thing on here, just touch here a little bit here, is on MLO. So MLO, Marcus, you were saying it was two. It's a little bit more than two now that are using it, but it's generally a technology that's only supported by flagship devices, right? So in order for MLO to work, basically a client, instead of connecting to the 5 gigahertz radio or the 2.4 gigahertz radio, it can simultaneously connect to both at the same time, or all three if you're using a access point with three radios and the client technology supports it, simultaneously connecting to all two or three at a time and broadcasting at the same time on those. Effectively, increasing how much data can be sent, because you can maximize the channel on your 6 gigahertz radio, simultaneously maximize the radio for 5 gigahertz or 2.4 or whatever, getting you that wider bandwidth. Um, but again, the client devices do have to support it, and that means they have to support broadcasting and receiving on multiple radios at the same time, and being able to support the greater amount of data that's going to be sent and received. So it requires a higher horsepower, both in the access point and on the client device. And since most client devices are battery operated, you're going to be blowing through your battery at a lot quicker rate. So for those reasons, oftentimes, even though a client device supports Wi-Fi 7, it will not support MLO in order to maximize battery life or to be able to perform other operations simultaneously without bogging things down, just handling the network throughput. And then to make things even more confusing, there are different ways of uh, of applying MLO. So MLO is not one technology, it is multiple technologies. And some client devices may support some types of MLO, but not other types of MLO. And to make things even more confusing, there are types of MLO which do not support the multi-part of MLO. So it is officially called MLO, but they only support a single radio at a time. So just to make things even that more confusing, just because your client device says it supports MLO, it may not be a type of MLO that your access point supports, or it maybe not be the fastest type, or it may not be a type of MLO that actually supports multi-link operation. It just supports a single link operation while implementing some other aspects of MLO, just to make things even more confusing. Now, the good news is, or at least when it comes to our access points, is we support all forms of MLO on the access point. So it's the client device that's going to be your limiting factor. Marcus, anything else I haven't touched on when it comes to the Wi-Fi 7 technology?
I think that covers everything. I mean, usually, one thing we can touch on is that MLO does, if I remember correctly, does require to use WPA3 encryption. So I know that we were seeing that in our test in our lab with the MLO on some of our access points, that it is a requirement. So that's something to keep in mind.
Okay. One thing I guess I think we sort of skipped or breezed over is 6 gigahertz support.
Oh,
So
yes.
yeah, so short version, 6 gigahertz is a new chunk of spectrum that, like 5 gigahertz, used to require licenses in order to be able to operate on it. So the FCC has opened this up for everybody to use without requiring any license. And the biggest benefit of 6 gigahertz is there's massive amounts of bandwidth available. So with 5 gigahertz, you've got two non-overlapping, non-interfering 160 megahertz channels. With 6 gigahertz, you have seven. So basically, 6 gigahertz gives you more spectrum than 2.4 and 5 gigahertz combined. So it's a massive amount of spectrum that's available for us to now be able to use. It was originally added with Wi-Fi 6E, and that has carried over into Wi-Fi 7. Um, so I did want to bring that up. Now, there are a couple downsides to it. Now, the first one is, um, as a general rule, as frequency goes up, coverage goes down. So
Yeah,
that
distanced.
means yeah, so you can't just swap out your existing APs and swap in new 6 gigahertz APs and have the same coverage area. Now, the coverage area will still be the same on 2.4 and 5, but if you want your 6 gigahertz coverage to be identical to what you've got now on 2.4 and 5, you're going to have to either rearrange your access points or you're probably going to have to add a couple new access points in there to cover it. The other challenge that we'll talk about is that 6 gigahertz can't be used outdoors without jumping through some hoops. And I think we'll probably save that for the Wi-Fi 7 challenges segment, which let's go ahead and start that now. Wi-Fi 7 challenges. So the first thing I wanted to talk about here, Marcus, and I'll let you jump in on this, is the question is, do you need to upgrade the rest of your infrastructure to support Wi-Fi 7?
Well, that's going to really depend on the access points specs because some specific radios for the access points do require a higher amount of power if it's PoE powered. They might require, 802.1, 802.3 BT for the power, which is 60 watts. Now there are some access points out there. We carry a few that do not require that much power, and that's mainly because on the boot up, when you boot up the access point, it requires usually there's a spike in power on the boot up, but you have to look at your access points to see if that particular access point requires that specific amount of power and you're using a PoE switch to power that access point, so you may need to swap that out. So I think that's one of the challenges that we see with a lot of customers. They want to go, hey, I want Wi-Fi 7, I want to upgrade, but then we look at it and say, hey, well, this particular access point is going to require a bit more power on boot up, so you're going to need to swap out your switches. That's one of the huge issues that we run into with a lot of our customers. It's something they don't really think about.
Yeah, so you end up in a situation where you either need to upgrade your switch. Um,
Or
we
PoE
all
injector.
I was gonna say, yeah, or we do sell
Yeah.
PoE injectors. We sell injectors with 5 gig backhaul that can do the 60-watt power output for you. Um, so you'll need to do one of those too. The other thing is most of our new Wi-Fi 7 APs can also be powered with USB-C PD. So you can use any off-the-shelf phone or laptop USB charger, and you have them that support power delivery of a, depending on the access point, probably somewhere in 40 to 60 watt power. But those are, inexpensive and easy to do. So you can always, if you don't want to upgrade your whole network, you could, depending on where you're mounting these access points, use USB power to power up those access points. And then I think that, Marcus, the other challenge we run into here is just the speed of your network. So even a
Right.
cheap NWA 130BE, it's $170 street price access point. It, in theory, has wireless speeds of over 10 gigabits per second.
So you need to upgrade your ports because older access points had what 1 gig for their uplink port, and so with these faster Wi-Fi devices coming out, you're going to need multi-gig. And if your switches don't support multi-gig with PoE, if you're going to power with PoE, you're also going to need to upgrade your switch because you need a multi-gig switch.
Yep. So it's something else to consider. I mean, you obviously don't need multi-gig to operate a Wi-Fi 7 access point. It'll still work just
No.
fine. It's just your wired connection now becomes your bottleneck for your
Hmm.
wireless users, where historically, your wireless was your bottleneck. These days, it's actually your wired connection that's going to be your bottleneck. Um, we've talked about coverage, about 6 gigahertz, not being, quite the same coverage as your 2.4 and 5. So we do get lots of questions when it comes to Wi-Fi 7 and using it outdoors. So I wanted to
Mm.
sort of explain what's going on there for people. So again, Wi-Fi 7 uses 6 gigahertz, 6 gigahertz, assuming so it is possible to deploy Wi-Fi 7 outdoors if you aren't using 6 gigahertz. But if you are using 6 gigahertz, you run into that faction or that problem where there are already existing customers using that spectrum that have paid for the license. Now, the reason we can use 6 gigahertz indoors without issues is again because as frequency goes up, range goes down, as does the ability for physical objects to absorb that signal. So the FCC isn't really worried about your 6 gigahertz signal leaking out of a building and causing interference with those legacy users. But they are worried about if you deploy the access point outside where the signal can go really far in the open air, that you are going to cause some issues. So the FCC did not repeat DFS and the nightmare that is DFS. They came up with two new ways to solve these issues with potential interference with existing licensed users. So the first one is you have to dial back the power really, really low.
Yep.
So the outdoor broadcast power is really low, um, and I don't think there's many hardware devices out there that are designed to use this because it's so low as to be really unusable for Wi-Fi use. So the other option is you can operate at normal or higher output powers, but your access point needs to know where the other existing licensed users may be and what channel those users are using. So that requires a specialty built access point that can physically determine its location, can reach out to the internet to a third party site, talk to that third party and say, hey, here's where I'm located. Which licensed users are likely to be operating in this area? Which channels are they using? And then which channels can I use? And at what power output can I use those channels? So by the FCC rules, your access point has to do that at least once every 24 hours. Now, the FCC doesn't maintain that database. Instead, there are a bunch of different third party companies that provide that as a paid service. So your access point needs to also support one or more of these third parties and be able to integrate with their back end. And you need to set up an account with them and probably pay a subscription fee to use that service. So that's why Zyxel in particular has been dragging their feet on implementing outdoor 6 gigahertz Wi-Fi 7. We don't want to come up with a piece of hardware that's only 2.4 and 5 gigahertz. If we're going to make the jump to 7, we want to make sure we support 6 gigahertz. And we've been kind of waiting for things to settle down on the third party rules and support and integration. Um, so that is coming, but it's still going to be a little ways off, at least for us, when it comes to deploying outdoor Wi-Fi 7. Um, Marcus, was there anything you wanted to add on that?
Yeah, like you said, that's just going to drive up the cost because if you're having to subscribe to multiple different third-party services, that just increases the cost for the particular user. So hopefully, once everything settles down, maybe there'll be a specific third-party client or third-party service that is the best one to use. I'm not sure, but I feel that eventually we will get there. But I think the cost is something that is considered when thinking about outdoor Wi-Fi 7 on 6 gigahertz.
Right. So that leads to our next topic, which is clients. So you need your clients to support Wi-Fi 7, obviously, to take advantage of Wi-Fi 7. Now, I ran into this conversation at a recent trade show with somebody who's probably should have known better. And they were looking at it and they looked at our access points because we have a series of access points that are called band flex. They support 2.4 on one radio, and then they have a second radio that supports either 5 gigahertz or 6 gigahertz. And the reason for that is, as you know, we were talking about earlier, to support three radios simultaneously, you need to start bumping up the power, especially if those radios are operating at faster speeds. So we wanted to provide a solution that's lower cost and works with existing 802.3 AT PoE switches and still gives you the ability to switch to 6 gigahertz in the future when more client devices support it, because right now a lot of client devices don't. And this person came to me and said, I don't get it, why are you still supporting 2.4? Why don't you give us an access point that supports 5 gigahertz and 6 gigahertz and just forget about 2.4? So Marcus, I'll throw that over to you. Do you know what the answer is, why it is we're still supporting 2.4?
You know, it could be, let's think about this for a minute. It could be the fact that, it's still supported on multiple clients. It could be, that's all I got really. I mean, when I think about it, it's just about supporting older clients. I'm
Yeah,
quite sure it's
so
probably the wrong answer, but still.
I wouldn't say older clients. What I would say is the vast majority of Wi-Fi client devices today out there
Still have 2.4.
support 2.4. In fact, I would
Yeah.
guess that the majority actually still only support 2.4.
Well, I would
So
I would agree to that because, just, I didn't mean to cut you off, but we
yeah,
had a customer that had a printer, that only had 2.4. It was one specific printer. It was, I think, I don't remember the brand, but that's all they had. It only supported 2.4, and so I think they turned on, I think they turned 2.4 off, and they were only operating on 5 gigahertz because they were thinking, okay, well, we want to have the most speed, most throughput. We're, trying to move away from 2.4. And then they're like, well, why can't we see this printer? And we tried everything, support was trying everything to get it to work. And come to find out, we're digging into the literature of that particular printer, only supported 2.4. So that kind of goes back to specific devices only supporting 2.4 gigahertz.
yeah, it's a lot more than people realize because I think most people are familiar with their smart TV, their probably $800 or more expensive phone. You know, even a cheap phone today supports 2.4 and 5 as a bare minimum. Your laptop probably does. But people forget that there are smart home devices, right? Those smart plugs, smart light bulbs, almost all of those are only 2.4 gigahertz support. And the reason for that is probably twofold. One is 2.4 chips are dirt cheap. And then secondly, a lot of these devices don't have to send a lot of data. So
Hmm.
why increase the cost of your device by putting in a faster chip when your device is really only sending small bursts of data? And it's not just a smart home thing. You mentioned the printer, but a lot of warehouse and industrial devices, same thing. They need wireless connectivity, but they don't need to send a lot of data. They're scanning barcodes. They're scanning QR codes. They're doing things like that, which don't require a lot of bandwidth. So again, they're only sticking in to this day a 2.4 only chip in there because it's the cheapest thing that they could find and that does everything they need it to do. So because of that, there is a massive amount of devices that only support 2.4. I mean, if I go today and go to Amazon and just buy whatever the first smart plug is, I can guarantee you it only supports 2.4. So in my house, I'm a tech guy. I've got all sorts of wireless devices. But I would still say probably my smart home devices outnumber my non-smart home devices, and the majority of those are going to be 2.4 only. So the reason I
Okay.
bring this up, is just because in order to fully take advantage of Wi-Fi 7, the client devices need to support it. So it's going to be a while before client devices catch up, especially when it comes to 6 gigahertz support. So it's going to be a while. I mean, right now, basically, it's only higher end phones and higher end laptops, and maybe something like maybe the newer Fire Sticks. Maybe I think the newer Fire Sticks support 6 gigahertz, but only the higher end ones. So it's going to be a long time before all of your clients can support 6 gigahertz. So
I want to
that
actually,
does,
oh,
Yeah, go ahead.
Oh, sorry. I wanted to say also, going back to the clients that only have 2.4 gigahertz, you also have to think about some smart devices have to be positioned kind of far from their base station. So maybe a camera, like a security camera, may only operate in 2.4 because they know that they want to get a far distance away from the base station. So if you have a 5 gigahertz on there, your distance is going to be limited. But if you have 2.4, you can go further than 5 gigahertz as well. So I think that's another reason why you see a lot of 2.4 gigahertz only on smart devices.
Yeah, yeah, it makes sense. It's something I completely forgot about. So anyway, my point being that's one of our challenges with Wi-Fi 7 is you probably aren't going to be able to fully take advantage of it for quite some time. Now, on the other
Mhm.
hand, it's if you're putting in a new network though, dude, don't you want to future proof yourself? Don't do you want to really
Mhm.
have to tear things out in 2 years or 3 years when 6 gigahertz is pretty ubiquitous? And then just the last challenge I want to bring up here is Wi-Fi 7. Some of the specs are changing. So the Wi-Fi Alliance has recently changed what features you have to get Wi-Fi 7 certified. So Marcus, you had brought this up kind of earlier tangentially when you were talking about MLO. So
Mhm.
going forward to operate in Wi-Fi 7, MLO has to be enabled. The Wi-Fi Alliance has decided it is not an option. It must be enabled, and your device must support it, at least on the AP and router side. Um, and going forward, you must use WPA3
Mhm.
on Wi-Fi 7. So I guess that's one of the benefits. Wi-Fi 7 with WPA3 solves some security issues that exist with WPA2. Now, the downside of that is there's a technology called dynamic pre-shared key, DPPSK, that's used by a lot of businesses as a way of providing 802.1x type per user password authentication for Wi-Fi networks without having to jump through all the hoops of setting up a radius server and using certificates and stuff like that. So that was sort of taking advantage of a loophole in WPA2. So come with our new firmware in July. If you set your radio to 7 to use Wi-Fi 7, MLO will be enabled by default. And if you're currently using DPPSK, you won't be able to use it anymore. You will need to set that radio into Wi-Fi 6 mode in order to continue using DPPSK, since DPPSK won't work or can't work with WPA3. So that's something people should be aware of. There may be some other changes coming up in the future as the technology matures and as the clients in particular start to catch up with where the access points are. Marcus, any other challenges you could think of that you want to bring up when it comes to Wi-Fi 7?
Let me see off the top of my head. I think that you kind of hit on most of them, specifically with the Wi-Fi 7 and all those particular challenges. I can't think of any off the top of my head right now, but I think that we've pretty much covered most of them, if not
Okay,
all of them.
yeah. So let's move from scaring you from away from Wi-Fi 7 to
Right.
answering the question, should I upgrade? And the answer isn't always going to be yes, you should upgrade.
Yeah. It's a difficult way to answer that question. It's really going to be depending on your needs and the client's needs, really.
Yeah, I think the way I look at it, there's no reason not to upgrade to Wi-Fi 7 if you are doing a new deployment.
Right.
Right. Wi-Fi 6 is what, 5 years old now, 6 years old now. If you go back to like the pre 6 stuff, I think it's even 7 years old now. So I mean, there's no reason to be throwing in something technology that's that old. I think it's a new deployment, do Wi-Fi 7, but I don't think it necessarily needs to be an access point that supports three radios simultaneously, unless that's what your users are asking for. I think something like our band flex devices are a perfectly cost-effective way of upgrading and deploying a new network now, which gets you that 6 gigahertz support in the future when you do need it. Um, I think though that Wi-Fi 7 is maybe something that opens the door for you when you're talking to your customers. Um, I think most of you out there probably reach back out to your customers every 3 to 5 years where you've deployed a Wi-Fi network. to check to see if it's still meeting their needs and maybe there's an opportunity there to upgrade. So I think Wi-Fi 7 is a door knocker there, right? It's going to handle crowded environments better, even when still using 2.4 or 5 gigahertz, because unlike Wi-Fi, what is it, Wi-Fi 5, 802.11
Right.
AC, which only upgraded the 5 gigahertz radio, Wi-Fi 7 does upgrade and deploy improvements to the 2.4 and 5 gigahertz radios. Um, so there are performance benefits that are there, even if you're not using 6 gigahertz on those 2.4 and 5 gigahertz channels. I also think it opens the door for those customers with deeper pockets to be able to give them a reason to upgrade their switch infrastructure. So it's not just a case of being able to sell them new access points. I think it's a case to be able to say, hey, isn't it time we upgraded your 15-year-old switches to multi-gig switches? Right. So you can support those faster speeds. Isn't it time maybe to upgrade your PoE, etc.? So I think it opens the door for you to have a full bundle solution, not just an access point upgrade solution to get you a bigger upgrade there. Obviously that's aimed at those of you that are VARs or MSPs. I think for end users, again, there's a lot of benefit there as far as upgrading 2.4 and 5 gigahertz performance. Um, the other technology maybe we're not looking at a lot is mesh.
Mm,
So
yeah.
for those of you that are old as dirt like me, you may remember when Ruckus went from being a WISP client device solution and tried to position themselves as a enterprise solution. And the way they did that is they said, hey, our smart antenna technology allows businesses to use mesh. And that was their big message. You couldn't go to a trade show anywhere without seeing ruckus banners promoting mesh. And I think any of you that are out there today will know that nobody has really been talking about mesh. Mesh itself was not a usable solution in large part because of the limited bandwidth available in 2.4 and 5. So, and Marcus, you can disagree with me on this, but I think 6 gigahertz and MLO opens that door again for the idea of being able to use mesh in a business environment. There's now enough bandwidth available that you don't run into those limitations that made mesh really untenable in a non-consumer environment.
Right.
Um, so that massive amount of bandwidth gets rid of the latency issues you had with mesh, the interference issues you had with mesh. And so now you've got that thing where if you do have a deployment and you don't want to run a new Cat 5 drop, new AC drop, you can use mesh to extend your wireless network without really having much of a performance hit, without saving you the cost of being able to do that. Marcus, any other ideas or suggestions on, when 6 gigahertz is maybe it's time to upgrade to Wi-Fi 7 and or 6 gigahertz?
Well, I think you hit the nail on the head about, using it kind of as a way to get your foot in the door because one of the things that we're seeing also with the Wi-Fi speed increasing is we're looking at overall ISP speed increasing. So you can kind of use that kind of as a way to leverage the conversation. If that customer is doing maybe an upgrade, a VAR reaching out to their customers every couple of years, they'll say, hey, what's your ISP speed? I've noticed that your ISP speed has increased. So you can sell a full stack. Hey, we have a new firewall out that can do multi-gig on the WAN. We can upgrade your switches and then also your Wi-Fi. You can upgrade to Wi-Fi 7 because there's a lot of customers out there who have clients that are, they want the best and the fastest. They want the bleeding edge technology. They want those particular things because they're looking to future proof. They're looking to take advantage of the new features that are coming out in Wi-Fi, and they want to be ready for it. They want to have it right now. So, like I said, I think you said about having your foot in the door. I think it does open that conversation for users to upgrade, how their clients upgrade to Wi-Fi 7. And there's also the concept of just looking at what their current needs are. What if they're deciding that, hey, we have way too many clients that are connecting, we're seeing a lot of slow throughput issues, we've added extra access points on Wi-Fi 6 and it's just not getting the job done. So that's a conversation to have with that client and say, hey, well, we have Wi-Fi 7, maybe it's time to think about upgrading to Wi-Fi 7.
Yeah, and personally, I don't think there's a lot of VoIP over Wi-Fi devices currently that support 6 gigahertz or MLO.
No.
But I really think that that's another key thing. So, voice over Wi-Fi doesn't require hardly any bandwidth, but it's always a huge challenge because of the interference issues, right?
Hmm.
Nobody likes that VoIP lag and delay. I mean, you've heard me and Marcus here stepping on each other's toes in large part, because of a bit of that. So that is something that 6 gigahertz and MLO will help solve. Because of the less interference issues, you need less buffer. You're going to be able to stream without getting those jitter issues. I think the other final thing here when it comes to Wi-Fi 7 and 6 gigahertz is high bandwidth applications. Now, there's not a lot of high bandwidth applications out there, but there are a few. And I think 6 gigahertz and MLO, because realistically, you can get actual data rates of over 5 gigabits per second wireless to wireless device. It starts opening up the ability to stream both audio and video without needing to recompress and then decompress the video. So reducing that latency and allowing you to basically send pure raw HDMI
Uncompressed.
essentially. I think
Right.
HDMI
Uncompressed.
for HDMI 2, I think is 4 point something gigabits per second. So it suddenly becomes very doable for you to just be able to send raw video and save yourself some of those latency issues and the compression artifacts that you may otherwise have. Um, I think that's what we've got here, Marcus. Do you want to maybe try recapping for us? Summary, I guess, of what we've discussed today?
Sure. So we basically discussed about how and when to upgrade to Wi-Fi 7. What are some of the things that you want to look for and ask maybe your clients about upgrading to Wi-Fi 7, some of the challenges for Wi-Fi 7, and basically a brief explanation of how Wi-Fi 7 works, and then also using Wi-Fi 7 outdoors with the 6 gigahertz, and why that's not a why that's a challenge specifically, and why we don't have, at least on Zyxel side, why we don't have an outdoor, 6 gigahertz Wi-Fi 7 access point. And then, of course, the brief history of Wi-Fi and going all the way back to what Wi-Fi 5 and going up to Wi-Fi 6 and now Wi-Fi 7.
Yeah, so as things sit now, we've got 7 different wireless access points that support Wi-Fi 7, and
Right.
we'll probably have some more coming out towards the end of the year. So I mean, it's worth taking a look. If you're one of our reseller partners, you're part of our partner program, reach out to your sales guy, Andy, David, Jacob, and get your hands on some of those. Put them through their paces, give them a try. It's not as expensive as I think a lot of people think. I want to say our cheapest Wi-Fi 7 access point has a street price of like 100 maybe double check here. I think it's $119. Certainly under $130. So it's not that expensive, and Wi-Fi 7 really does compete with Wi-Fi 6 on price at this point. Um, so I think
Yes,
that's
you might as well upgrade. I mean, if you're looking at price to price, might as well take the latest technology.
yeah. So I think that's it. So I just want to thank everybody for listening to us talk today. There will be some more episodes of our podcast coming out. We also do webinars almost every week, and take a look at our YouTube page. So it's what is it? Zyxel America channel is I think the name of our channel. It just rolls off the tongue there, but that's where you can see some of our old webinars. Um, We've got on there video case studies. We've got product announcements. We've got some best practices videos. So if you haven't yet, check out our YouTube side. And otherwise, thank you for joining us. I hope you join us in one of our future podcasts.